This particular set is going to go through a lot of information, simple information, it's a good part, rather fast, but with examples, so that's a good news. And that's relational operator, algebra, and operators. I gotta be careful about that. This is a theoretical way of manipulating table contents just to get query results using relational operators such as select. So there's going to be commands that I'm going to give you that are relational operators. Now, we can think of this as basically being described in mathematical terms, so that's why they use relational algebra. Anyway, but you're also going to have some that are very similar to what you've seen in discrete math. Now, that's not going to be in this particular set for this document. It's going to be a next set of notes for a little bit further down. But we're going to go over here in a second. But I want to get to the important part. The important part is this is where your SQL queries are getting to. I know you know that's coming up. That's where all of this. So you're going to start learning a little bit of SQL, MySQL, whatever, to do exactly what you want this, not theoretically, but for real. So just a heads up. The relational operators have the property of closure because we can use relational algebra operators on existing relationships that are already there to produce new relationships, which is really going to be here. So let's go with select first. Select is going to do all that, but here's the important part. Select all yields. So we're going to look at our original table that we have here, and that's going to basically, frankly, well, display the same darn thing again. Notice, by the way, I've had it, so notice this is original table and new table. Think of this as our query result that's going to come out. By the way, this also happens to be select, where I'm selecting all items, or I can get to a little bit more interesting items. But notice, the order doesn't have to be the same, by the way. So I believe it is the same between all three, these two. It doesn't have to be, because remember, order doesn't exactly matter. So this could be garbled up a little bit, but 1, 2, 3, 4, 5, 6 is always going to be with the flashlight, and the price is always going to be 5.26 in whatever order and results is going to come out to be. So this, frankly, you did this, you're not doing much because you're just displaying the table over again. So let's get to the good ones. Select only price that's going to be less than $2, and that's where we start getting more and more into our depth and query of what the power of databases and tables are. Notice it's going to get all the P code, the product description, and the price that's obviously less than $2. And then notice we can change this up. We can have a very particular selection too. So notice there is going to be some condition, and yes, the condition this time of true or false or something of that nature that we're used to in programming, that'll help us. That single equals is really a double equals for those of us in programming. So that would give us our product code and exactly what the match would be for that one. So that's how we're doing select, is grabbing, I wouldn't say certain pieces of data, but the criteria of data that we're looking for. Here's project, and I'm a big debugger type of guy, and project, so notice I'm not saying project, I'm saying project, like projection. So if I wanted to project the price of what it yields, then it would just go ahead and display the price. If I wanted to project the product description and the price, I would get both of those. And then product code and price. So there's 3 different types I can get from this particular table. Now, again, it really knocks down what I don't want from it more than anything else. So that's project. But we have other commands in MySQL and SQL that could do that. But again, I want to make sure you understand it's projections. It's not project for this particular one. So this one can be a little bit more interesting, and that's a union. And this is combine all rows from 2 tables, excluding duplicate rows. But here's the important part. The tables need to be a union compatible, which means the tables share the same number of columns and their corresponding columns to be able to do this. So notice in both of these, and this is, I want to make sure you understand, these could be different size tables. Maybe you're not seeing all the attributes here and there. For both of them, maybe they're slightly different. To me, I have a problem once in a while. Maybe there's some data redundancy in this, so that's a problem for design-wise for me. But notice it's the same number of columns and they're labeled the exact same thing, which again bothers me, in order to create our overall union of the two different tables. Now, you might have a table of, these could be toys and these could be food products. So notice that you can't have that. This looks like it's a bunch of big hardware, and this is some smaller stuff that you might find at Walmart. So notice it's two different product setups. So yeah, that would make sense of why this is set up, but still, I still have a problem with that. But anyway, that's where we could have a union between the two tables. And again, they've got to share the same setup when it comes to how many attributes that you're really asking for. Is your discrete math class starting to bring back some memories here? Intersect yields the only row that appears in both tables. And by the way, this is actually really, really powerful because this also helps with redundancy. Is that here we have Franklin, Johnson in both the tables, which may be legit, but also it kind of helps us determine that, hey, personally, I was actually a student and a professor at the same time. We have, and that caused problems, by the way. So we can have some type of intersection between two groups that has a meaning and may have a meaning for the application that we have here. So intersection is really, really important to identify those types that do share and have, well, their different yields in both of the tables don't intersect. They're kind of special. So in product, I'm going to be, let's look at the tables. First, here's all the different products that we have. And here is two important things. Each store that they're going to be housed in and what particular aisle or shelf that it's going to be in. So all of these are going to have flashlight, lamps, box fans, batteries. Every store is going to have one. So that's why you have the product of that, because every store, so let me see how I can do this here. Store number 23. If I were to just highlight the store for 23, it's going to have one of the flashlights. It's going to have one of the lamps, the box fans, and you're going to tell me exactly where it is for that particular store. So to be very honest with you, I would have not done it by product code, but I would have sorted it by the store itself, and that would have made maybe a little bit more sense on how things are set up. But notice that they do it by flashlight, lamp, and that's fine. That's fine. But me personally, again, thinking about design and application here. So that's what a product would be used for.